So we want to be able to solve radical equations. A radical equation is an equation that has a variable under the radical. And so here are some steps for solving it. You can sometimes think through it other ways, but here are ways that we can work through it. And the first thing we want to do is isolate the radical. That means get it by itself on one side, so you're kind of solving for the radical. Next, you're going to square both sides to cancel out the radical, the square root. If it's a cubed root, you cube both sides. You solve for the variable and make sure you check your answer, because when you square root both sides you can get some extraneous roots. And so we'll start with this first one. We're going to subtract 5 from both sides. Subtracting 5 from both sides, that isolates the radical for us, which was the first step. We get the square root of x equals -2. And then following the steps, we would square both sides. And that gives us x equals 4. And then we want to make sure or check that so we can put 4 back into the original. So we're going to check it. And we have the square root of 4 plus 5 equals 3. Square root of 4 is 2. 2 plus 5, well, that is not a true statement. 7 does not equal 3. So 4 is not a solution, and so actually there is no solution. Excuse me. Now we could have noticed that back up at this step when we had the square root of x is equal to -2, because there's no number, we can't take the square root of any number and ever get to, or a negative number, because a negative number squared equals a positive, and this won't work. So we could have known here that there's no solution. Our next one, we're going to follow these steps again. We isolate the radical, or solve for the radical, so we're going to add 2 to both sides, which gives us a 12 on the right side, and we have 3 square root of x plus 4 is equal to 12. To continue isolating, we would divide both sides by 3. That gives us the square root of x plus 4 is equal to 4. We're going to go ahead and square both sides to get rid of the square root. And a square root cancels with a squared because they're inverses, so we have x plus 4 is equal to 16, and we can go ahead and subtract 4 from both sides to get x is equal to 12. Again, we want to check, so we're going to put 12 in there, so we have 3 times the square root of 12 plus 4 minus 2, and we want that to be equal to 10. 12 plus 4 is 16, and the square root of 16 is 4, so we have 3 times 4 minus 2 equals 10. This is 12. Minus 2 does equal 10, so it works. So x equals 12 is our solution. A few more examples, and these are working with exponents, and so we want to solve for exponents. And here you see the steps we can go through. Write the bases as a power of the same number. Simplify the exponents if possible. Set the exponents equal to each other. So that's going to be for some of these over here for the second and third example. This one, we want to solve for x. So we want to get x by itself. So we're going to do the same idea. These are just very large numbers, and we don't want to multiply out 5 to the 43 for sure. So we're going to go ahead and just work through the same idea that we would. That's times 5 to the 43. We're going to add that to both sides. And so over on the left side, we're just left with 5x. On the right side, we have 2 of these things, or sorry, 7 of them, plus 2 more gives us a total of 9 times 5 to the 43rd. And we would divide both sides by 5. Now this one works out that we're dividing by 5, which is the base of this exponent that we have, so we can do some reducing here. This 5 will reduce with one of these There's 43 5s multiplied together. We'll reduce with one of them to make it 42. And so we're left with x equals 9 times 5 to the 42nd power. So that's solved really like a regular linear equation, and that's what it is. It's just that we have very large numbers. These next two are the ones that we're working with here because these are equations with variables in the exponent. And notice both of these examples have variables in the exponent. So write the bases as a power of the same number. So this is 3 to the 4x. So we're hoping we can write 81 as 3 to a power, which we can. Hopefully you know that 81 is, well, and if you don't, you can do a factor tree. This is 9 times 9. And these are both 3 times 3. And so we have 3 to the 4th power. 81 is 3 to the 4th. And so we were able to write them as the same base. Set the exponents equal to each other. Use the fact that if bases are equal, then their exponents must be equal. So 4x has to equal 4. That's a nice easy thing to solve. Equal 4. Divide both sides by 4 and you get x equals 1. So x equals 1, we could check that by plugging back in. 4 times 1 is 4. 3 to the 4th is in fact 81. The next one we have to again write our bases as a power of the same number. Now both 25 and 125 are powers of 5. And so I'm going to start by doing that. I'm going to write this is 5 squared to the 2x, or to the x. So I'm replacing 25 with 5 squared. Over here I know that 125 is 5 cubed, but that's in the denominator. So this step here, we'll work with the left side. Something to a power raised to a power, you multiply the exponent. So really this left side is 5 to the 2x. The right side, when we have an exponent in the denominator, we can bring that up to the numerator, but we have to make sure we use a negative exponent. And now we have 5 to a power equals 5 to a power, so therefore those exponents have to be equal to each other. And we get 2x is equal to negative 3. Dividing both sides by 2, we get our answer, which is negative 3 halves, or negative 1 1/2. And x equals negative 3 halves. So we solved radicals with a variable under the radical, and then we were able to solve things with variables in the exponent. There are many other problems like this that don't work out like this. These ones were chosen because they can be written with the same base.